Hello, now I'm going to describe how can you implement the domain model layer, which is a layer of persistent objects and implemented with object orientation. And basically I'm going to show how we tag, annotate this layer, write annotations in this layer in order that provides information to the data access layer such that it deals with the persistency of information, and the moving of data from the database, the loading of data from the database to memory, and writing it back to the database. Okay. So I can show in the code. So I'm going to focus actually in our example. So I'm going to show how the student dashboard is implemented persistently, considering that the course execution entity already exists and the student domain entity already exists. Look that the student dashboard actually implements a many relationship between student and course execution. So each student dashboard associates a student with a course execution. Okay. So how can I represent this? And the idea is that I'm going to show you that we can use a notation that is pretty close to the UML representation. So, as you have already know, we go to the domain package and we find the dashboard class there. In this dashboard class, you have the first thing. So you have is a class. It's a Java class dashboard, and you need to implement from domain entity for because of some visitors you have already implemented here, but which is not relevant for you. Because of this, the only thing you need to do is to define an empty method for an acceptor. Okay, but that's not your concern. And the first thing you need to do is to say that this dashboard is an entity. So you have to annotate this with entity. This is a keyword, a JPA keyword, saying that the instances of the dashboard class will be persistent. Okay, and we'll deal with that with you using the data access layer. The second thing that you need to do, you did define an attribute, which is an identification, and you say that is an ID. And actually, although not necessary, but you say that the way the strategy is generated. So actually, we need to provide a unique identifier for each persistent object. That's only the reason you need to write that, but every class you're going to define to be persistent need to have this. Okay. Then you have the normal attributes of a class, okay, which actually are the attributes that are defined there, right? And now then you need, how do I model these relations? Okay. And what we're going to do here is I'm going to say that I have a relation, an attribute, course execution, that is many to one. Okay. What does it mean, many to one? It means that when I'm here, I'm many on this side to one course execution. So basically, when I am in a dashboard, I can access a course execution. And the same applies to the student. So if I read the code, I have a student and I have a many to one. And JPA will deal with the managing of these relations. Okay. Now, what is the last thing we need to describe? So this class will be persistent and will be related with that. The next thing we need to decide, which is the final one, is, because if you look, there's no more, this is pure Java class, okay? The other thing you need to decide basically is that in these relations, if they are going to be implemented with bidirectional relations or unidirectional. It means that if it is bidirectional, I say that when I'm in the dashboard, I can access the course execution, and when I'm in the course execution, I can access directly all the dashboards, and the same for the student. Okay, so you can decide what to do, and basically it only depends if now in these classes you define the inverse mapping, okay, to be bidirectional. We decided here that course execution will not refer to the dashboards, because actually course execution already refer to the students, and this will be pretty redundant, okay? But the student should have his dashboards. So why? Because when you are in the student, you want to know what are the dashboards of this student, okay? So these relation will be unidirectionally implemented, and these will be bidirectional, okay? And another thing is that, look, this is a many-to-one relations. So we have many students, a dashboard has one student, and a student has several dashboards. So when we map these, we map with an attribute, right? With a student attribute. But now, in the other direction, you need to map with, of course, a collection, a Java collection. So let's see how do you map it. So I can move to the student, and in the student, we'll find this here, okay? So in the student class, look, it's an entity, okay? And this entity, you have a one-to-many. So it's one to many, okay? And on the other side of the many, you have dashboards. Here, we have decided to implement it as a set of dashboards. Could be a list, if you prefer, okay? We decided to implement it. And the final thing that is relevant here is this. What does it mean? The first thing is mapped by. You need to know, you need to say to the student what are the attributes that is going to look on the other side. So it's the attribute student. So to connect both annotations, okay? So it's the mapped by. And the second thing is this cascade all. What this it means is that when I'm going to delete, if I delete a student, I want to delete all its dashboards. So the delete cascades to all. So it's to be automatically deleted, okay? This is related with the semantics of the, and you decide each case whether you want to cascade or not. Another thing is orphan removal true means that if for some reason I disconnect the dashboard, so I say to the student equals to null, what happens is that this dashboard will be automatically deleted from the database. And the way to say it is to say orphan removal, okay? And basically, that's it for this type. We'll find other types of relations like many-to-many, but actually in your project we'll need to use one-to-many, many-to-one. Okay, good.